Hi, I'm Mrs. Ferguson, and I'm going to show you how to do both parts of number 7 on the Chapter 1 closure packet. So for part A, it gives us a function in the function machine, and then it says that the input is -8, and we have to find the output. So, and notice I rewrote the function in the function machine, but where the x's were, I left blank because we're going to be plugging in -8 for x, because x is our input. So we're going to take the -8, we're going to plug it in for x. So this part, I'm going to go ahead and actually fill in -8 here because we're finding f of -8. It doesn't mean f times -8. It means we're actually plugging in -8 to the function called f. So over here where x was, I'm going to put -8 there in place of it. And then I'm just going to simplify this. So thinking about PEMDAS, order of operations, since this -6 is right next to these parentheses, this is multiplication going on here, and we would do multiplication before we would subtract. So -6 times -8, a negative times a negative is always going to be a positive, and 6 times 8 is 48. And then we have the -3. And then we're going to do the subtraction, and 48 minus 3 is going to give us 45 as our output. So we just replaced x with -8 and simplified. For part B, we have to kind of do it backwards because in this part, it's saying that we want an output of 21 and asking us what the input would have to be. So if we think about, we want to end up with 21 coming out of our function machine. So we have to figure out what x value would give us that when we simplify. There's a couple different ways you could do this. You can just kind of think about it. So whatever -6x is, when we take away 3 from it, we should end up with 21. So I'm just going to think about what's a number that if I took away 3, I would get 21. And that number would have to be 3 more than 21, so that would be 24. So 24 minus 3 would give me 21. I'm kind of thinking backwards through this. But that means that this part here before the 3, the -6x, should be 24. So -6 times what would give me positive 24? Well, a negative times a negative would give me a positive, and 6 times what is 24? That would be 4. So my missing x value must be a -4, and that's what my input would have to be. Another way you could do it, if that was hard for you to follow, is you could set it up as an equation. So you could take the -6x minus 3. We want that to equal 21. So you could actually just write that as an equation and then solve it by getting x by itself. So we would add 3 to each side to undo the -3. Then we would divide by -6 on each side to undo the multiplication by -6. And 24 divided by -6 is -4. So that's a different way you could determine that the x value must be -4 to start with, is to just set this equal to the output you want and then solve it like a regular equation.